divide this into two videos, one for the logarithmic functions and one for the exponential functions. The thought process is actually quite similar on both of them, though. I need to graph, this would be the parent function for just a base 5 logarithm. One way to remember this is if I rearrange this into exponential form, it's the base of 5 to the y power equals x. So I actually approach logarithmic functions sort of backwards from the way I would approach graphing exponential functions. I kind of go with y first and then I find my x instead of x first and then finding my y. So if y is 0, anything to the 0 power is 1, so x is 1. If y is 1, 5 to the first power is 5. 2 would be 25, but that's off of the graph. If y is negative 1, 5 to the negative 1 power is 1/5. Remember, it's a reciprocal. 5 to the negative 2 power is 1/25. So what I notice is this is never actually going to cross the y-axis. It's going to get closer and closer and closer all the time, but never actually reach it. That's why the y-axis in this case becomes what is called an asymptote, which is an imaginary line that my function will approach but never quite touch. And I say imaginary, it's not really an imaginary line, but if you're going to actually graph your asymptote, you do it as a dashed line because the line itself is not part of the function. Domain is all of the x values of this curve. Now, it never ever actually touches the x-axis. So the left side of this is 0 is less than x. But it continues forever in the positive direction, so is less than or equal to positive infinity. We're going to write these in what is called interval notation instead of just writing x is greater than 0. The range. This goes down forever, and even though it kind of looks like it levels out, it never becomes purely horizontal, so it always has some vertical movement. So my range on all of my all of my logarithmic functions is going to be negative infinity is less than or equal to y is less than or equal to positive infinity. X-intercept, where it crosses the x-axis, is the point 1, 0. If it crossed the y-axis, I would put the y-intercept as well, but it doesn't, so I don't have a y-intercept. My asymptote is a line, so it has to be a linear equation. In this case, they're always going to be horizontal or vertical in this unit because of the kinds of things we're graphing. So the vertical line, where x equals 0, is the line that this function approaches but never actually reaches. The transformation of this is very similar to the transformations that we did in Unit 1. When I see this x minus 3, I know that I'm going to go right 3, and the plus 4 at the end means up 4. So what I do, the way I approach this, is I just go back to because my base is 5, 5 to the y equals x. Where would that initial point be, and then where do I need to move the point to satisfy this transformation? So when y is 0, x was 1, but I'm going to go right 3 from there and up 4. So that point I move, and I just move one point at a time. When y was 1, x was originally 5, but now I'm going to go right 3 and up 4. Then I'd be off the graph after that. When y was negative 1, x was 1/5. But I go right 3 and up 4. And I know if that was at 3 1/5, this is going to be 3 1/25, etc., etc. So now I have my new curve, which I really struggle to draw neatly on this thing. Hopefully yours is better. I'm trying to get to where this doesn't quite touch that, but obviously I'm not very good at it. So, my domain. Well, it never actually touches where x equals 3, because x equals 3 is my asymptote. So 3 is less than x, which is less than or equal to positive infinity. Again, it's going forever vertically, so negative infinity is less than or equal to y is less than or equal to positive infinity. I can almost talk today. And it does cross the x-axis here. Now, I know it's at 3 and something, but I could solve this equation if I wanted to, but I could also stop and think, well, if this was at 3 and, let me see, this was at 3 and a fifth. This would be 1/25th, so 5 to the negative 2. And then 5 to the negative 3, 5 to the negative 4. 5 to the negative 4 power is 1/625th. So my x-intercept is at 3 and 1/625th, and y is 0. That should look like a very large 3, not 3,625. I could also have solved it by saying, well, to find the x-intercept mathematically, the x-intercept, it's when y is 0, so I could substitute 0 for y is the base 5 log of x minus 3, and then plus 4. I would subtract 4 because I want to get the logarithm by itself, so negative 4 equals the base 5 log of x minus 3. And then when I'm solving these things, if I get stuck in logarithmic form, I change it to exponential form. So 5 is my base to the negative 4 power equals x minus 3. So x is 5 to the negative 4th power plus 3, which is 3 and 1/625th. So I could have gone to the work to solve it if I couldn't figure it out the other way. I am noticing in this case the x is being multiplied by 2. So this is a horizontal, and remember the horizontal ones are kind of backwards from what you think it should be, shrink. So normally if y is 0, x is 1, but it's only going to be half that. Normally when y is 1, x is 5, but it's going to be at 2.5. I'm going to pull it back. Normally it would be at 25 here, so it's going to be at 12.5, which is still off the graph. Normally at 5 to the negative 1 power is 1/5, but it's going to be half of that. It's hard to see any difference, so 1/10. And I'm going to draw in my curve as best I can, trying not to actually hit that axis. It's really hard to do that. So my domain, my asymptote, is still the vertical line x equals 0. Make sure you have to write x equals 0. If you just write 0, that's not a line. The domain then, 0 is less than x, which is less than or equal to positive infinity. The range on all of these is going to be the same. Negative infinity is less than or equal to y, less than or equal to positive infinity. And in this case, my x-intercept was the 0.10 originally. Now it's the 0.1/2, 0. This is the one that gets to be kind of tricky, one of the ones that gets to be kind of tricky. Remember that my horizontal translation, or my horizontal shift, is based on whatever is added or subtracted from the x, not from the 4x. So what I really have to do is to factor that 4 out, and then this would be x plus. Now remember, if I'm factoring out, it's kind of the opposite of the distributive property. If I distributed back in, 4 times x would give me the 4x. 4 times whatever's here would give me the 7. Well, if distributing is multiplication, then when I'm factoring out, I'm actually dividing each of these terms by 4. So 7/4 is 1 3/4, which in this case I could write as a decimal, and then this minus 3. So I know that I have a horizontal, in this case, shrink, factor of 4. I'm going to go left 1 3/4 and down 3. So I go back to where I would have gone with my original base 5 logarithm. Y to the 0 power is 1, so I would have been at 1. But I'm at 1/4 of that, so I'm at 1/4. And then I move 1.75 to the left. So if I'm at 1/4 and I move 1.75 to the left, I would actually be at, oh goodness, I'm having to do negative 1.5, but then I'm going to move down 3. 5 to the first power is 5, but I'm going to be at 1/4 of that, so 1.25. Moving left 1.75 puts me at negative 0.5, and then my y is going to shift down 3, etc. 5 squared is 25, but a quarter of 25 is 6 1/4. So over here at 6 1/4, but I'm going to move left 1 3/4, and then go down 1, 2, 3. So I get my points in, and I end up with this kind of a curve going. And now notice, my asymptote was at x equals 0, but it's shifted now left 1 3/4. So my asymptote's actually going to be at negative x equals negative 1 3/4 now, which apparently I am incapable of graphing this properly. I'm really not even trying to get to -2. What sometimes you can do is to take a straight edge and let me do the line, see if there's a way to do a dashed line. I could actually, and change my color to make this stand out, I could sort of do a, oops, not that big. I could do, and you see this on graphs sometimes, a dashed vertical line at 1 3/4, and then try to approach that so it's a little bit easier to see that visual on my asymptote. So my asymptote is the vertical line x equals negative 1 3/4. So my domain, it never actually gets to negative 1 3/4. So negative 1.75 is less than x, which is less than or equal to infinity. My range on all these is going to be from negative infinity to positive infinity. In this case, though, I actually have both an x and a y-intercept. Somewhere out here, it's going to cross the x-axis. And right here, although I can't exactly eyeball it, it's crossing the y-axis. So for my x-intercept, I'm going to go back in both cases to this original function. For my x-intercept, it's when y is 0. So 0 equals the base 5 log of 4x plus 7, and then minus 3. Well, I'd add 3 to both sides, so 3 equals the base 5 log of 4x plus 7. Change it to exponential form, so 5 cubed equals 4x plus 7, which means x, 4x, let's do this a little more slowly, equals 5 cubed, which is 125, minus 7. So x equals 118, 125 minus 7, divided by 4, which means my x-intercept is going to be at 29.5. So x-intercept is at 29.5 and 0. My y-intercept is when x is 0. Somehow I did not calculate that one yet on my paper. So y-intercept is when x is 0. So y equals the base 5 log, well, 4 times 0 is 0, so of 7 minus 3. I don't want to add the 3 over here. What I'm noticing though, I could use the change of base formula here. So y equals the log, base 10 log of 7, or natural log of 7, divided by the log of 5, and then subtract 3 from that. I'm expecting this to be pretty close to -2, but not quite -2. So hang on just a second. I'm going to, in my calculator, the base 10 log of 7 divided by the base 10 log of 5, and then subtract, not divide, subtract 3, and I get -1.79 to 2 decimal places. Oops. So my y-intercept is when x is 0 and y is -1.79. If you want to see the second part, watch the second video.